Thank you very much. So, Mr. Matsuo, please take your stage. Thank you.
Thanks for the introduction. So my name is Kazuki Matsuo, CEO and co-founder of Xfusion. So Xfusion is like a laser fusion company based in Osaka. So we aim to electricity by 2030 and also a gigawatt class by 2040. So actually there are many issues in the world today, but the one of the most issue is like a decarbonization challenge. So by 2050, so we need the 6 terawatt of the, we needed replacing the 6 terawatt of the energy. So by 2050 to achieve the decarbonization. So of course, like wind and solar energy is like very good energy resource, but still we need the large amount of the energy. So laser fusion can supply such energy. So with the decarbonization. So if the laser fusion will supply half of global energy supply, making such company as the world's most valuable company. So we aim to become such a company. So first, I will explain about what is laser fusion. So first, as you can see, that it's like time is left to the right. So first, we prepare the deuterium and the tritium. It's like a hydrogen isotope. It's an ice ball. That's very small. It's just a 3 millimeter diameter. So we compress using the nanosecond pulse laser to compressing this fuel. And after that, we using the picosecond pulse laser to heat it up. In this case, the fuel become a high dense and also high temperature. Then a nuclear fusion is occur. After the nuclear fusion occur, the fuel emitting the neutron, and we capture the neutron using the called blanket. It's kind of liquid metal wall, and converting to the heat. And the heat converted to the electricity. So in this process, we do not have no CO2 emission, and actually the abundant energy resource, and no meltdown, and on-demand power. So that's why many people think that fusion is kind of the ideal energy source for the future. So this is our path to the laser fusion power. So of course we are a startup, so we need to build a small scale to the large scale. So first we aim to actually we already have the own facility in Hamamatsu. So actually we built it in 2023. So and this facility mainly focus on the continuous operation of the laser fusion reactor. So which means that we prepare the high repetition laser system and also laser iming system and also target injection system. Because like to achieve the laser fusion reactor, commercial laser fusion reactor, so we needed to operate this reaction at 10 Hertz. 10 Hertz means 10 shots per second. In this case, we needed to inject in the target 10 Hertz repetition rate, and also we aim to this target to using the laser at 10 Hertz. So our first, the milestone is like a continuous operation of the laser reactor, and actually it's done. So now we try to move to the continuous neutron demonstration. So which means like we try to prepare the more high power laser system, and if we use a high power laser system, we can get the continuous neutron. And after that, we need to building a more high power laser system, and also we installing the blanket. Then we can demonstration of the power generation at 2030. So after that, if we can build the large number of the laser, then we can get the gigawatt class of the reactor 2040. So this is kind of the Xfusion's unique selling point. So Xfusion is focused on the in and out around the reaction chamber, especially laser beam and laser beam control, and also fuel target injector, and fast wall blanket. So actually there are many things here, but I will try to explain about that. So as you can see, the first, of course, we need the laser, because we are laser fusion. So in the laser fusion, we need a nanosecond pulse laser system. So actually it is easy to build the high energy laser, just high energy. But the problem is like we need the high energy plus high repetition rate of the laser, which means a high power laser system. So because like we needed to create such a condition more than 10 hertz, which means like repetition rate should be the more than 10 hertz. So, and also we need the beam controlling system. So because our target is just 3 millimeter, so we needed to aim this 3 millimeter ball from the more than 10 meter far from the target system. So actually, it's very difficult to aim to the laser, aim to such a small target. And also, target injector is very important because we also need to inject the target at 10 hertz ratio, and the velocity of the target is 100 meter per second. It's very high speed. So we needed to inject in the high repetition rate using such a coil gun injector. So after the fusion occur, I say that a neutron is emitting, that the neutron is captured by the liquid metal wall. So we made this system using the lithium lead. So we collaborate with the Tokyo Tech University to making such a lithium lead with high purity. So we have such a component, and we try to integrate all system. And the small system is in Hamamatsu now, and we hope to build the more bigger integrated system in the future, in near future. So anyway, this is kind of the technological mode. So we, of course, we build a laser and laser beam control and liquid metal and also reactor design here. So we try to integrate all components as a one system. So so one other thing is the uniqueness is a method of the laser fusion, because 2022, so actually the laser fusion reached a break even. Break even means the installing the energy and also output is the same, more than output. So we already achieved such a condition, but problem is that we need the very high energy source for the input. But our method called fast ignition 10 times higher efficiency, and we already wrote some of the paper in the physical regulator, so 2020 and 21. So and also DOE, so U.S. government mentioned that this cited that my paper, so in their reference. So actually, this is a PDF, so I can show the movie, but so this is kind of the demonstration of the our continuous the creation of the laser plasma. So as you can see here, very small tiny spot here. So actually this is kind of the plasma. So we injecting the target from the outside, and we aim to the laser system to this small piece, and we creating the plasma. And we succeeded to this creation with repetition rate of more than 10 hertz. So right now, so we need to build the more high power laser to get a continuous neutron emission. So anyway, this is a team. So I'm CEO, and also CTO is coming from the GPI, which is like a private university in Japan. And also there are many talented researchers almost in Japan. And also we have the partner in the globally, so like UC San Diego or UC Berkeley, or some other party here. So finally, so laser fusion is unleashing infinite energy for humanity. So the human history is kind of the conversion of the energy, the heat and steam, electricity, and now we can get the light, laser. So laser fusion is kind of the creating the heat using the laser. So if we can get such a the energy source, so I think it's we can save the humanity. Thank you.
Thank you very much, Mr. Matsuo.